Hi class, my name is Sakshi Shori. I am an OPSM 5850 student. I work as a principal lead in one of the very tier 1 telecom operators, and that's why I have today chosen 5G as my presentation topic. I'll be discussing 5G rollout and some design considerations that we need to keep in mind while planning 5G deployment. Also, we will discuss how 5G is revolutionizing our global supply chain industry. Let's start. This slide talks about the journey of mobile networks today and tomorrow. 5G continues to be the evolution after 1G, 2G, 3G, and 4G networks. Technical improvements for 5G, right, which is the fifth generation of cellular mobile network technology, it includes faster data speeds, reduced latency, and improved network slicing. Slicing allows the cellular network to be divided among customer systems or devices. We'll talk more about this slicing and other features in detail in the next slides. But 5G is still a developing technology, and most of the cellular service providers won't complete an end-to-end 5G infrastructure on their public networks by around maybe 2025 or 2026, around that time frame, which means that the companies are building their own 5G networks for the specific use cases and individual facilities to take advantage of this technology ahead of competition. You can see here mainly Internet of Things is driving this technology, right? And for Internet of Things, you need higher data speeds, reduced latency, more bandwidth, and this is what it is all about, right? So we can see the possibility of big multinational companies establishing their own networks to ensure the highest level of availability, quality, and security. So they do not want to compromise on all of these things, the quality, the security, and high-end availability, right? Now, so the supply chains in particular, they are the ripe for the 5G driven capabilities to feed the growing appetite of data to drive inventory and transportation management optimization and predictive analysis. So for any company that is not thinking about all this, it's already too late. Now, 5G brings with it endless possibilities and promises. For those who are not very familiar with this technology, 5G technology, it may simply appear that like it's an upgrade to any existing system. Maybe this one may be a little faster, a little better, and nothing too world shattering, right? But this is an inaccurate analogy for what 5G promises and what it is offering today. This technology is not just about speed, it's about device density and latency as well, which is transforming the entire telecom industry or enterprise. So if you see this slide, like you can see that that 4G doesn't allow too many devices per area, right? Say for example, the current 4G technology allows only about 10,000 devices per square mile, right? This is why dense population centers compete and struggle for bandwidth, right? But with 5G, these kind of issues will be over, right? Oh, because 5G is offering over 1 million devices that can operate within the same area. This is the advantage of 5G over 4G, right? The huge number of devices it can operate within the same area, right? So this is about 250 times growth in capacity, right? While 4G casts a white shadow to cover all these devices, expending energy indiscriminately. 5G uses this massive technology known as MIMO, which is multiple input and multiple output, right? For multi-target user tracking, which gives high improvement in speeds, capacities, and coverage. So basically, in terms of pure bandwidth, 5G is nearly about 8 times faster in speed, and and sorry, it boasts of more than 5 times the bandwidth, which is huge as compared to other 4G and 3G services or technology that has been there in the past. This is a quick peek about how 5G differs from 4G. We can see here that 4G, the major difference is the number of connections. In 4G, only one radio connection is allowed at a time, but with 5G, multiple connections can happen within the same area simultaneously, right? And 4G is a single network for video and machine type traffic, but here we use network slicing. So if we slice them, we can use those slices for different needs. The 4G was one of the first steps, into virtualization and cloud computing, right? But here in 5G, fully cloudified networks and applications exist. So which is one of the major differences, and all these basically allow higher capacity and faster speeds for 5G when compared in respect to 4G. There are certain considerations that need to be kept in mind while doing the planning and designing of a service, right? So as we all know by now, after reading the module 3 of the course, that capacity is the amount of output that a system is capable of achieving over a specific period of time. In services, this output is seen as the number of customers served, but when it comes to manufacturing, this output is viewed differently as the number of units produced. But our use case that we'll be discussing here will be 5G as a service. Now, capacity must be available when a service is needed. This is what we read about in strategic planning unit of module 3 in the course. Now, it cannot be stored. Similarly, service must be available at a customer's demand point. If the customer is demanding a service and the service is not available, there is a risk of losing that customer, which is called churn when it comes to telecom. Right. Now, the transition to 5G requires an extremely well-planned and a focused approach for all these operators to effectively execute their technical strategy, right? Because they need to meet their business goals, and if their approach is not focused and well planned, it may not give the value that the operators is looking for, right? Now, the diverse nature of these use cases really demand stringent requirements related to capacity, data rates, speeds, latencies, densification of the network, and even the availability and the reliability of the network. So the use case selection and timelines are really the key to prioritize the infrastructure transformation, right? Now, when we talk about the planning and design phase of 5G as a whole, right? Now, the infrastructure should be considered end to end for a transformation, which really includes these three different paths, right? One of them is a radio access network, which is your RAN. The other is the transport, your backhaul, your U-haul, and your data center connectivities, right, across different data centers, right, through the transport. And the third is the packet core, right? So all these three are very important when you talk about the transformation of the infrastructure end to end when it comes to 5G, right? So as discussed in the current module as well, that there are all these are capital intensive resources, right? One of the critical steps in this phase is to conduct a readiness assessment of your current infrastructure and then analyze the gaps and the requirements, right? There's a methodology that can be incorporated, or it is recommended to conduct this readiness assessment and then build a design, um, uh, build a plan to design the next generation network for these kind of services. So deploying 5G can be challenging. It's challenging because of the network complexity, depending on the use case, and the migration that needs to take place from the existing setup and transforming into a new one, right? So there are certain steps that need to be used to deploy this 5G. So the step first includes the infrastructure and network function deployment. And this includes the migration of infrastructure from current to the new one, right? So it is highly important to transform the infrastructure to be able to get the best value of your service. The next step is the network slicing. The best way to achieve a sliced network is to transform it into a set of logical networks on a top of this infrastructure that was developed on in the first step, right? So each logical network is designed to serve a defined purpose and compromises of all the required network resources which are configured and connected end to end. So the first two steps are really important and critical, right? Infrastructure and network function deployment and network slicing and onboarding. The next step is the application servers and MEC. MEC is a multi-access edge computing that moves the computing of traffic and services from a centralized cloud to the edge of the network, which is more closer to the customer. This is what we want. We want it more closer to the customer. So instead of sending all the data traffic to a cloud for processing and the analysis and storage of that data, these steps are highly required for deploying the 5G network, right? The next is securing a network and operating a network. Securing a network is very critical as it acts as a on-ramp for the internal networks to access the internet, right? It's kind of a center for internet security. And finally, operations. The network operations is an operating system that manages the network resources is internally, especially the operating system and other resources. So these are the 5 steps that are required for deploying a 5G service. One of the key challenges today is the varying capacity and the coverage demands, which are non-uniformly distributed over space and time. So in our current wireless network these days, there are small cells that are really deployed at some fixed locations, and those locations were planned during network planning, right? So therefore, there's a lack of flexibility of reacting to spatially varying service requirements. Dynamic radio topology is one of the emerging concepts in 5G that addresses these issues, and the real-time provisioning of services is made possible by means of flexible network deployment in 5G. So it is highly important that the infrastructure processes and the resources are flexible, which means they have the ability to quickly adapt to the change. Some of the considerations in changing capacity basically include managing the bottleneck operations, the cost of upgrading less frequently or too frequently, and the temporary and permanent reductions of resources or infrastructure, or managing the outsourcing of shared facilities. So all these should be kept in mind when we talk about the flexibility and the adaptability to quickly adapt to a change. Lastly, let's see how 5G is revolutionizing our global supply chain. So, as you all know, that we are now living in an era of supply chain of one, right? Where the consumers demand personalized product and services, and they want minimum lead times, they want lower cost, and they want the location of their own choice where they need the product to be delivered or service to be delivered. This has been a driving organizational requirement for real-time information, decentralized decision making, and integrated systems and capabilities focusing on customer experience more rather than just the product functionalities and capabilities. Therefore, supply chains need to reduce their impact on the environment, right? And how we can do that is by faster speeds that will enable improved operations and balance customer expectations, and faster speeds is definitely what 5G is providing, right? The next benefit is the cloud computing, cloud edge computing. That will also save supply chain some time and bandwidth, right? So all the advantages of 5G, being it faster speed, being it computing capabilities, and its increase in reliability and availability is revolutionizing our global supply chain. Thank you, friends. Thanks for listening. I will be available the whole week to answer any questions you may have. Please put those questions in the comments or in the discussion area, and I will get to those answers as fast as possible. Thank you.